All right, lesson 20, solving exponential equations. All right, this will be a little bit quicker. I keep saying that, but this one, this one actually will, I think. Okay, so there's a few, like we ran this problem before, right? Where, like in the last lesson, where we had an x, like I'll just show you some of the examples down here, right? We've got like an x up in the exponent, and we didn't really have a way to solve that algebraically yet, but we were able to solve that by graphing. So let's say like in this case, right, we were able to say, okay, graph this is y1, graph this is y2, and then figure out where they cross, and that's my answer, right? That'll always work. Like that's still a way of doing it, but we're gonna start to figure out some ways to do this algebraically as well. So this is the first way. This way doesn't always work, but it's probably a little bit easier, I guess. And then the second way is going to involve using logarithms. So here's our way of doing it. We're doing a rewriting it basis, right? So a little bit of review here. So we could rewrite this number 81 as, you know, anything that's still equal to 81, right? And they're asking us to write it with a base of 3. Okay, so really, I could write it as 3 to the power of 4, right? That's the same number. So all I've really done is rewrote 81 as 3 to the power of 4. This will make sense in a minute, I promise. So now this one with a base of 3. Okay, well, little hints here. 27 is, like, I'm looking at that. It's in the denominator, but I'm still kind of looking at that 27 because I'm like, okay, well, I know 3 to the power of 3 is 27. So let's just do that for a second. Let's write this as 1 over 3 to the power of 3 to the power of 5, right? It's just the same thing. Okay, well, now if I look a little closer at this, right? 1 over 3 to the 3. Well, that's actually the same thing as 3 to the power of negative 3. Do you remember that, how it switches, right? So if I went 3 to the power of negative 3, like the other way around, you'd say, okay, well, that flips that as 1 over 3 to the power of 3, or 1 over 3 to the power of 3. That'd be the same thing, right? So I'm going to rewrite this purple bit, right, as 3 to the power of negative 3. And then remember, that's still all to the power of 5, so I'm not quite done yet. And then using our exponent law here, that if you have a power to a power, we multiply. So I'd rewrite this now as 3 to the power of negative 3 times 5 is negative 15. So there you go. So we're rolling with that base now. All right, next one. So we've got 3 times root 3 to the x. Okay, well, let's write this here as 3. I'm just going to call this 3 to the power of 1 just for a second. I'm going to say, okay, this is 3 to the power of 1 times, and then root 3. Okay, well, a little bit of review here. If you remember, if I have root 3, and then this is really squared, right? And if you had that, you don't need to write this down, but if you had that, let's say to the power of, like, 4 or something, I could rewrite that whole thing as 3 to the power of, and then the top number, 4 over, and then the bottom number is the root. So that'd be like 4 over 2, or 3 to the power of 2 in that case. Okay, so we can do the same thing with just the square root, right? Square root of 3, that's the same thing as 3 to the power of 1 over 2, because it's a square root, right? The bottom number is the square. Okay, so that's the idea, and it's all of that to the power of x. All right, well, looking at the inside here now, we've got 3 to the power of 1 times 3 to the power of a half. So looking back at exponent laws again, what do you do if you have, exponent and you're multiplying, and then so same bases? So what do we do with those exponents? We add, right? So we'd add those exponents. That ends up becoming 3 to the power of 3 over 2, or 1.5, same thing, to the power of x. And I could write that a little bit cleaner, because now I can just go 3 to the power of 2 times x. So that's 3 to the power of 3 over 2x. Okay. All right, so now this one. So, okay, so we got 9 to the power of negative 2. And then this one's 81. So those aren't even the same numbers right now, right? But what if, for a second, let's just rewrite that 9 as 3 squared, right? So I'm going to write that as 3 squared. And then all of that was still to the power of negative 2. So I'll write that again. So negative 2. Okay. And then times now all this, right? So instead of 81, I'm going to rewrite that as 3 to the power of 4. Okay. And because of the cube root part and the squared, right, I can write that in one move. I could say, well, that's the same thing as 2 over 3, right? That's just, all right, that's just 81. And then, well, anything here, right? Let's say we just had like some number that was cubed and then squared, right? So some number squared, then that would be, let's say it was x, so that would be x to the power of 2 over 3. That's all I did there. Okay, now we're just cleaning things up, right? So now at this point, well, let's go, well, multiply our exponents, right? So 3 to the power of 2 times negative 2 is negative 4 times, and then 3 to the power of, and then this is 4 times 2 over 3, that's 8 over 3. Okay, so we're almost there. Now, what do we do when we are multiplying? Well, we add, right? So the next step here is we need to go negative 4 plus 8 over 3. So that would be negative 4 plus 8 over 3. I'm going to multiply both sides by 3 here. So that's the same thing as negative 12 over 3 plus 8 over 3, which is equal to negative 4 over 3. Okay, so that was just adding those exponents. So that's what this is, right? This would be 3 to the power of negative 4 over 3. Okay, so that's the idea there. Now we're going to put this to use, right? So the idea here is if we're solving for x, so let's say like in this example here, if we write everything with the same base, so let's do that first. So I'm just going to rewrite the first one. I'm going to say 10 to the power of x plus 4. And that's equal to, and then I'm going to rewrite 1,000 as 10 to the power of 3, right? Just rewriting that guy. But then that's still to the power of x minus 4. So just all this stuff is up in the exponent now, right? So now if we look closely at this, we can say, okay, 10 to the power of some number is equal to 10 to the power of some number, right? Either way. And if they're equal and I got the same base, then what must be true is that x plus 4 must be equal to 3 times x minus 4. So as soon as I get to this point, then I can say, really you'd say therefore, right? Those dots. Then you could say, therefore, x plus 4 must be equal to 3x minus 4. And then you're pretty good to go, right? Now you guys have done tons of this, right? So could expand that out. So we got x plus 4 is equal to 3x minus 12. I'll get my x's on the same side, numbers on the other here. So we'll say, so minus x, and we're in a room. So we get 4 is equal to 2x minus 12. So plus 12 plus 12. So we got 16 is equal to 2x. And then lastly, divide by 2. So divide by 2. So x is equal to 8. Oh, 8. Okay. Okay, let's do the next one. Okay, so 25 and 125. Okay, so can't directly see it, but just, you might have to do a little bit of guessing and checking to kind of figure out what it would be too, right? So I'd start being like, okay, so, 4 to the power of something, no. 5 to the power, I know 5 to the power of 2 is 25. And I know 5 to the power of 3 is 125. So, okay, so let's rewrite those. So I'll rewrite 125 as 5 to the power of 2. Okay. And then that's still 2x up there. And then that's equal to 5 to the power of 3, right? That's 125. And then times x minus 1. Okay, so good to go. I mean, I made my brackets kind of funny there. It doesn't really matter how you do it, but you don't even need them at all if you don't want. Anyway, so now same basis, so I can make them equal to each other. So we'll say, therefore, it's not therefore. Therefore, 2 times 2 is 4, so 4x is equal to And then I'll just write it as 3x minus 3, just expanding that one out. And then I'll bring, so minus 3x minus 3x. So we get x, that was easy, is equal to negative 3. All right. Okay, so let's do the next one here. Hopefully you guys didn't run into a room here too. Okay, so we got 8 to the power of x plus 2 is equal to 1 over 4 x plus 3. All right, so now I'm looking at an 8 and I'm looking at a 4 and I'm like, okay, so can I go 4 to the power of something to get 8? No. I can go 2 though, right? 2 could be my base, right? Because I could go 2 to the power of 3 is 8 and 2 to the power of 2 is 4. And then that kind of got me there. Like this might be a little confusing because I got 1 over 4, but remember, I'm going to be able to handle that by going negative, right? I'll be able to say 4 to the power of negative 2, okay? But so let's do that. So let's rewrite the 8 as 2 to the power of 3 and then times x plus 2 is equal to, and then like I said, I'm going to rewrite this guy as 2 to the power of negative 2. If you don't like that, you could have like done another step there as 1 over 2 to the power of 2 and then put it up, but that would be the end result. And then it's that times x plus 3. Okay, so I got the same basis, so I can say therefore 3x plus 6, just expanding that in, is equal to negative 2x minus 6. Okay, so then plus 2x, so I got 5x is equal to, and then minus 6, and then minus 6, so that ends up being negative 12. So then divide by 5, so we get x is equal to negative 12 over 5. Okay. Okay, tricky little one. How are we going to get that same base out of this, right? This doesn't make any sense. But because I got a 1 and I got a 121, this is a dirty little guy. So here, I'm going to rewrite this as 121 to the power of 2x minus 5. And that's equal to, and then here's the little shifty one. I could rewrite this 1 as, well, what about this? 121 to the power of 0. Because anything to the power of 0 is just 1. Okay, well, that worked right now. So now we can say, okay, those are the same. So we can say, okay, well, then 2x minus 5 must be equal to 0. Okay, well, this one's easy. 2x is equal to 5. Divide by 2, divide by 2. So x is equal to 5 over 2. Okay. Now, when they look a little funny like this, I can see, okay, something's going a little wrong here. Here, other than that's in the way. Okay, so this doesn't look like the others, does it? Right? The other ones had like, one term and one term. This one has something like multiplied beside it. Like it's just getting really messy, and I can't do anything with 21 really in the 9. So what we're gonna do here, I'm gonna recommend is try to get these in 2 nice pieces. So the way we're gonna do that is I'm gonna divide both sides by 21. So we're going to have 1 over 9 to the power of 4x is equal to, and then 7 over 21 is the same thing as 1 over 3. Okay, that looks nicer, right? Okay, so 1 over 3. Now, let's rewrite this a little bit different again. Let's write this as, well, this one, I'm going to write that as 3 to the power of negative 2 times 4x. And I'm going to write this one as 3 to the power of negative 1. Okay, so now distribute. So we've got negative 8x is equal to negative 1. Okay, divide by 8, or negative 8, divide by negative 8. So x is equal to 1 over 8. All right, next one here. So now graphically, right? And we actually did a little bit of this in the last one there too. So I'm actually not going to spend too much time on this because I think you guys will be fine with it. This is the way we've been doing it, right? So if you were solving for x, like in this case, where you say like we got 5 and we got 3 for our bases, there's no way I'm making those the same base, right? This is not going to work out. So the only way so far that we know how to answer this is to graph it. So if you graph this, you would end up getting something like, I don't even know, something like that and something like this. And it's where they cross, right? But like I said, we've done tons of that. So I'm sure you guys are used to that one by now as well. So same thing with this one, right? You just graph it like it actually is and go from there. So that's pretty much it. So that's going to end that one.